Okay, so what we're doing today is we're building a high voltage EMP device. All right, to do that, we're going to need, this is a dimmer switch. This is a 6 microfarads capacitor. And this is a 6-volt car ignition coil. So what I'm going to do now is I'm going to wire all these things together, and that's going to take a little bit of time. All right, this is the capacitor, the 6 microfarads capacitor. This is the dimmer switch. The dimmer switch is just a regular dimmer switch you would wire into a wall. This for lights. This is from a fan. It's any electric motor, like a ceiling fan or a box fan of that size, will give you this capacitor. 6, 5, or 4 capacitor. So I got the 2 wires there. I'm wiring them together on one side. And I'm going to put a wire cap on there. Test the wire cap's secure. Right, that's one side. The other side of this is going to go to a power cord that's going to plug into the wall. This is the ground. So from this side of the capacitor, what we're going to need to do is wire it to either the positive or the negative of the terminals on top here. One's positive, one's negative. So to do that, I'm going to use this red wire to signify hot. Okay. And this is all going to be contained in this right here, very close, so I don't need a big run of wire. There it is. I think this wire is like 10 gauge or something, or excuse me, like 16 or 18 gauge. That would be fine for what we're doing here. So I've got that much, and I've got this much. And I take another wire connector. Wire nut. Here's a wire nut. And give it a quick twist. You know what size. Okay, now I make sure it's all connected. It is. Now for the other side, I'm going to do something a little bit different. Got a nice lead there of exposed wire. What I'm going to do is I'm going to use these ring studs, 16 to 14. I believe this is a 16 wire. It might be an 18. Either way will make it work. This is the ring stud. I'm going to put it in this side. Okay. And it pokes through the outside there like that. That's how I know I've got it in there. And then I'm going to crimp it. Squeezed on there nice and tight. What I'm going to do is put a little bit of tape. These attachments sometimes they don't get most secure. All of this is going to go under oil though, so this tape's not going to do diddly. Diddly squaw. Okay, wrapping it up though. So I want to get that nice, good. All right, and now we've got dimmer switch, capacitor, and a terminal lead. I'm going to take that terminal lead and I'm going to put it under the, let's do positive. You can see that's why we have this stud, to fit on this terminal. See, all of this is going to go in here together. More or less like that. Because this is all going to be filled with oil. All right, now this is a ignition coil wire. I like using these because they fit square right in the top of here, like that. So that's where we're going to go ahead and put this for now. You can just put any old wire in the top of these ignition cylinders, but I like these ones because they got the boot. It's a little silicone boot that covers it. And then the other side, this is going to go to the first, this part is going to go to the first part of our spark gap. Okay. So just to recap, this is all we have so far. A dimmer switch, which is turned on slightly open, to a capacitor, electric motor capacitor of 6 microfarads, straight to the ignition cylinder, and it's on the positive terminal. That's the positive, that's the negative. You could do it either way, to be honest, but positive makes more sense theory-wise. Okay, so we're going to put that all together, or all back down in here. We're not done with that though. And then from the top of this is where the high voltage, this right here, this wire is where the high voltage is going to come out of. Okay, so we've got another side of this terminal here. This is negative. What we need to do now is we need to wire this into this this 3-blade plug. We need 3 blades because we got positive, negative, and ground. And we're going to use positive and negative to send the voltage to the car ignition coil. And then we're going to use ground for the spark gap. And our spark gap's going to go to ground. So we need to get a GFCI tester like this one to get a correct ground in our house. We cannot plug this into any old outlet in our house. We need to make sure the outlet is correctly grounded because we're going to be utilizing the ground. And if it's not, you're going to blow circuits. All right, so here's the cord I'm going to use. Okay, there we go. So one of these is positive, negative, and ground. Green is always ground. Okay, all that really matters is that we get this in the right order. It doesn't really matter if we use positive or negative. What matters if we just put it in a loop, the whole circuit. Use what you got. Okay, so that's ground. This is gonna go, this is in a house, this would be neutral and this would be hot, but really it's positive and negative. Or yeah, positive, negative. Positive is the one that shocks you. So what we're going to do is we're going to put the positive side onto the first part of the dimmer, and I'll pull this back out again to show you the loop when we're done. I'm going to twist this like so. That might be big. Yes, no, just got that. Now, that's all pretty much good there. Almost, actually. We got to do the other side of this. So we're going to need a small run of black. Black to signify negative. There's my small run. Small section of wire. I'm going to strip the ends. On this end, I'm going to put another ring stud. This is the ring stud. Okay, and then it's going to go on the other side, on the negative side. Okay, so we've got the positive side going back to the capacitor, going back to the dimmer, and we've got the negative side that's going to go straight back to the power cord. So now I'm going to tighten both these nuts. I'm not going to over tighten it because it's easy to do so. Do I do on the other one? Throw a little bit of tape on there. It's fine, nice and secure. Tape was unnecessary, to be honest. All right, and this is the circuit so far. I'm going to take the neutral side of the power cord. This again is the power cord, right? This is what we're going to plug in. Take the neutral side, which is the white wire, and I'll put it on the negative side of this terminal. So that's the loop. It goes, and the ground's going to hook up to the spark plug, or excuse me, the spark gap. In a car, that would be the spark plug. Okay, that's all connected. We've got our loop, our circuit. So it goes from hot to dimmer switch to capacitor to hot, dimmer switch, capacitor, ignition coil on the positive side. On the negative side, we just take it straight back from the ignition coil to the wire. And that's because AC goes like that. It's not direct current, it's alternating current, so it goes back and forth. That's the loop of friction, so to speak, electrical friction, that's going to cause what we want. Now we've got a ground here. We can go ahead and we can take this ground and we can put it into this ground, knowing that later, we don't really need to though, to be honest. Knowing that later, we're going to undo that ground and we're going to put the ground from the spark gap in it. Just twisting that up. So there's the circuit. Now we're going to put it all in this container. And this container is going to contain oil. That's why we're using the container. But right now we're not going to bother with the oil because it'll just be messy. All right, so this is where the high voltage is going to come out of. This is the cord in which we just wired everything. This is the lid for this boy right here. So we'll go ahead, we'll put that like this. Like that. And then as you can see, I need to drill another hole right here. That's why I was looking. So I'm going to go get this stuff for that. And then we'll have this container nice and finished. Pretty much, I'll just have to secure this side with everything the way it should be. Okay. The diameter of this wire is about this auger. So I'm going to go ahead and I'm going to put the hole right here. I took the boot off to do this. So look at that, nice and perfect. Goes through there. On the back side, I'm going to put the boot back on. The boot's coming in the middle. The boot goes back onto the ignition cylinder. Okay, just like that. I'm going to tighten that down. Put this through the top here. Okay, just for now, I'm going to use a bit of tape to keep this from moving around. Later on, I'm going to want to secure this better though. But I still need to open something here or have access here to pour oil into. And eventually, this is going to go into this power strip. And this power strip is going to be secured. And then we're going to have an ice on-off. Okay, so that's the high voltage power supply. It really is as easy as that. All right, the container part of it is the trickiest part. But now we've got this supply coming off, and what we're gonna do with this supply is we're gonna put it into a bracket. All right, I'm gonna go and use a specialized power tool, a grinder, and I'm gonna cut two pretty decent sized pieces of this stainless steel cable. If you're doing this, get yourself a thinner piece of stainless steel cable so you can just use wire cutters. Okay, now I've got my two ends cut. What this is going to be where this high voltage comes into, and then it's going to be a spark gap, and then the other side. So these are my spark gap leads. The reason I use stainless steel is because it's the least becomes the least corroded with high voltage, least oxidization. So the first thing I'm going to do is I'm going to roll this back, and I'm going to try to figure out how to get this to be a permanent attachment. It's going to take me a little bit. I opened that up. I'm going to slide that in as best as I can. Okay, this metal tab here is the conductive part, so that's what needs to touch your spark gap, stainless steel, or whatever you use for your spark gap. You can use any metal. Like I said, though, stainless steel just works the best. Get that nice and secure. So I'm going to squeeze down. This is another reason to use these wire ignition clamps. They make nice clamps, or wires, excuse me. It's because of the clips. And I'm going to slide this boot back over this connection. Not that it's that important, because as of right here, this is all going to be exposed. All right, so it's going to go something like that. That's going to be the configurement, because over here we're going to plug in. We want this to be right about here. Okay, right about here on the board. Power strip's going to be here. Spark gap's going to be here to here, and the paddles are going to rest over here. So at this point, we've got ourselves a semi-permanent setup. So what I'm going to do is I'm going to unplug this, plug it back in later, because I want to start fixing some of this to the board. And I don't want to fix the container to the board till the very end, because the container is the most important. Well, I just want to make sure this spark gap is in the right spot. Okay, so it's right about there. I'm going to take my trusty hot glue gun I've already turned on, and I'm going to put some hot glue down just to keep this spot nice. And by keep it nice, I mean keep everything in the order that it should be. After this, I'm going to put this other side in, this side, right here, and I'm going to keep the gap pretty small, because I don't want it to be dangerous. The larger the gap is, the more dangerous it gets. And then from here out, what we're going to do is we're going to take some wire, and then we're gonna start funneling it into, it's not the right word, we're gonna wire it into paddles that we can operate. That's gonna be a whole nother procedure. That's pretty secure. This one we're gonna plug back in. No, not yet. Got some zip ties to keep everything in place. Now what I'm gonna do is I'm gonna zip tie this, well, Yeah, I'm going to zip tie this in place with 2 zip ties. So I don't want the spark gap moving around at all.
This is pretty self-explanatory, but what I've done is I've taken a bit. It's the same width as the cable ties, or the zip ties, excuse me. And now I'm zip tying one of the ignition wires into place. That ignition wire that I'm zip tying in place is going to hold the first stainless steel cable that will be this spark gap tool. I don't know what you call that. Spark gap electrode. There it is. You can see I want to make sure that's really tight and it's really secure, because we do not want this spark gap moving around if it's jostled while in use. And you can see the spark gap there. It's a little bit long, so I'm going to cut it. I'm going to try to cut it. I won't be able to.
Okay, I went ahead and I shortened the spark gap thing, whatever. The spark gap attachment. Alright. Now I want to keep this distance really short. So that's what I'm going to do.
There I am. I'm drilling more holes. And at this point, I realized that my plan isn't going to quite work the way I had it thought out. I'm going to have to shorten those spark gap electrodes. I still go ahead and I drill a hole and I get it ready, even though I know I'm going to have to change the plan. And when you're tinkering, that's pretty normal. You just got to change your plan. You got to think it out what you're doing.
This is Romex wire. There's 3 wires within it. This is for wiring a house. I'm going to use it for this because it's got the best insulation.
And what I should have said here, but I'll say throughout the video, is you twist these wires together once they're stripped, and functionally then you have one wire. So that's what I'm doing. I'm stripping it and I'm going to twist it. I don't know if I do it off screen.
For this wire, you want the wire to be insulated well. And I'm actually going to reinforce the insulation on this one with some saran wrap. Okay, so what I'm going to do now is these leads from the wire, they're all going to get wired into here. All right, I just got lucky. I had another ignition wire I forgot about. What I'm going to do is I'm going to put the other side of the stainless steel wire that I cut. There it is. Into this side, just like I did this side. I'm going to put it into there, and then I'm going to clamp it. And then I'm going to secure it to the board, just like I did here. See, I've got these nice clips here I should be able to use. What's nice about using metal on metal is you get that tensile strength when you clamp down, which is obvious. All right, that's not going anywhere. Just like that. So that's our spark gap right there. And then we're going to drill more holes.
Okay, I should have said that, I should have shown you, but the end of the ignition wire has got a clip on it that you can bend with a pair of pliers. That's what I'm talking about. I bent those clips to hold the stainless steel cable. It worked fantastic.
All right, what I just forgot to record was I got this other ignition wire. I put it down. I clipped it to the stainless steel on this side. Again, this is the spark gap. So I want it really tight. I went ahead and I crimped it down. I zip tied it all in place. I crimped this copper wire. There's 3 wires here on the other side. And that's all she wrote. It's as easy as that. Now what I'm going to do is I'm going to get the PVC that are going to be the handles for the paddles. Okay, these are going to be the 2 handles. So what I'm going to do is I'm going to glue those in place with the heavy duty clear PVC cement.
Okay, I included this part for everyone that hasn't done this before. It's very simple when you apply this PVC glue. What you do is you coat the inside of whatever is going to go, whatever's going to sleeve into it, you coat that side. And then you just pop it on, you give it a little bit of a twist to make sure the glue spreads. And that's that. And I'm doing it again.
These are 2-inch PVC pipes. So now what we do is we take this lead and go all the way up through here. To right here. Right at the end. And this is going to go to a coil. Okay, so what we had so far is we've got the circuit, which is from the hot, which is this black wire right here. This black wire, 3-prong plug. Took the 3-prong plug, I cut the end, separated it into the 3 wires. This black wire gets plugged straight into the dimmer switch. The other side of the dimmer switch, the other black wire from the dimmer switch, goes to a capacitor. This is a 6 microfarads capacitor. I got this from a electric fan, a box fan. Right, that's just scrapped off of it. It's pretty easy to find it. It's fairly big. It's near the motor. That in turn gets plugged into the positive side of this car ignition coil. The part number will be listed below the video. That's one side of the circuit. The other side of the circuit is this white wire. This is the neutral load in a house. This white wire goes straight into the negative side of the car ignition coil. On the car ignition coil, I use these special stud rings. Stud rings just make it clamp better. You could strip the wire, wrap it around there, and then screw the bolt down, and it would be fine too. But I just like to have it a little more secure. It's not necessary though. All of this goes in this compartment here. Right, that's why it's all messy like that, is because all of this is going to have oil in it when we're done. And the important part is we cover these terminals with oil so we don't get any sparks. These terminals of the car ignition coil, and then this dimmer switch. This is just a regular house dimmer switch. Again, the part will be listed. Okay, so off the top of the car ignition coil comes the high voltage. The high voltage will go back into the ground, which is this green wire here. But that's the very last step. So all of this is going to be like so. See, that was backwards. You want the car ignition coil to be on the outside. And I want these to be here like that for the sake of room. I got that all planned out already. I want these wires to be on these nuts to be just on the outside. Okay, and then the car ignition coil top, the wire is right here. So this board is actually backwards. Let's move that for just a second. So from the car ignition coil, and I'll show you this again when it's done. From the car ignition coil, you've got this wire right here. This will plug right into the top. of here, just like this, through the plastic lid. This will shoot off high voltage that will go into this spark gap right here. This is the spark gap. You want to keep the spark gap tight. And from there, this will go to ground. This whole wire will go back into the green wire here, which will be plugged in here. Okay? So this is just a car ignition wire. I used it because it's got the clips and I had it because I'm buying these car ignition coils, so why not get the wires too? This is the first coil. This is for the first paddle. This is 2-inch PVC. That's a 90-degree PVC connector, and inside it, I've got wire coiled. Okay, I've got, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 layers of coil. I don't know if you can see that very well. And what I'm going to do now is I'm going to finish duct taping this all in place, just so make sure we get no movement. And then I'm going to saran wrap the top here. And the saran wrap, or the plastic wrap, this material right here, is going to provide more insulation. So when this is used, there's minimal, if any, electrical feeling getting through. You could call that a shock, but it's going to be, if there's anything gets through, it's going to be far less than a shock. It's going to be like a tingle, like a violet ray wand. So that's what I'm doing right now. Is on, and on one side of the coil, so imagine a coil of wire, like this. That's what's on the inside of this right here. It just looks like that. This side would be from this wire here, and this side is this unattached wire down here. So we got one wire coming in to this coil, right? There's a coil on the inside of this, a coil of wire. One side going in to this coil, wrapping its way up, and then from the top going back down, the coil coming out. And that's this. Or the wire coming out, excuse me, and that's this. And this wire will go into this one, where I will repeat the process. One wire coil comes up, one wire connects to the coil that goes up, wire goes down, another wire comes out, and eventually that will connect to this ground here. And that will be done. And I'll fill this up with oil and we'll test it and be done. All right, so that's the process. I'll show it to you again. That was just a quick explanation of what we've done so far and what we're going to do.
All right. So that's the first paddle, and it's gonna, you see how it's attached to the ignition wire of the other side of the spark gap electrode. All right. So what happened is when I made that, the camera failed. So this is the next day or later that day, and you can see I'm just using duct tape here to reinforce the coil I put on the inside. The coil is on the inside of the paddle at the edge of the 90-degree. It's the same one that you're going to see later in the video that I did record. So don't get too caught up in that. The Romex wire that's attached to the ignition wire on the other side of the spark gap electrode is going straight into the paddle, and it's the beginning. It's with a wire nut. It's connecting to the wire that's making the coil. And by the way, the wire that's making the coil is the same wire bulk wire that I used in the beginning to make the high voltage power supply. It's like 18 gauge or something like that. 18 gauge braided. 18 gauge braided, anything higher than that will be fine. So I covered the paddle with saran wrap or plastic wrap, and now I'm reinforcing that plastic wrap with duct tape. And what's great about plastic wrap is it's made of PVC, so it's like just a fantastic insulator that's really, really cheap. You can't find an insulator that's easier to work with and as cheap as plastic wrap. I use it for everything now when it comes to insulating. If it's going to touch my skin though, or something like that, for like building a capacitor to wear or an inductor capacitor to wear, what I do is I shield it with duct tape, something that's like vinyl, something that's safer for my skin to interact with. There you go. The first paddle is about done. It's covered completely. Looking pretty good. So I've got one Romex cable going into it and one Romex cable going out of it. And the Romex cable going out of the first paddle goes directly into the second paddle. There I am. I'm stripping the end of the second Romex wire. They're all 8 feet long. They can be as long as you want them to. I feel about that length is the most functional because you're going to use two potentially at the same time of these paddles, so you want some length in between them. You'll see at the end what I'm talking about. There I go. I'm stripping it. It's slightly off screen. That's what I'm doing off screen. I'm just stripping that Romex and I'm going to twist them together to functionally have one wire. You cannot, again, Romex is so cheap because it's used in most new construction. It's used in most houses, I should say. Apartments, whatever. Most residential. Most commercial, too. It's one of the #1 building supplies. Okay, so that red wire I'm holding, that's the 18 gauge braided wire I was talking about. I'm getting a wire nut. I'm connecting that 18 gauge braided wire to the Romex, and that's going to start my coil at the end of the 90-degree attachment. So there I am, twisting it up. Like I've said many times now, cutting it to the right length. And now I'm fastening the wire nut and the coil, and I'm testing it. Okay, for this part, this is hot glue. Just hot gluing it in place is, you don't need to, but it just helps. You want to be able to do all this stuff and have your wires secure, because what I'm going to be doing, that coil is kind of delicate. So then I'm pressing it. Just the hot glue, it can be such a nightmare getting that to set sometimes. But eventually I do. I give it a little tug with my teeth. I was actually trying to hold it. Just trying to keep it in place. Playing the waiting game. Alright, we're going to jump ahead. Right, this part, what I'm doing is I am getting that beginning of the coil started, or trying to. This part's actually pretty difficult. And I'm hot gluing the Romex to give it stability. And there I have. I've got it started. And how you get it started is there's this slight lip on the inside of the 90-degree attachment, the 2-inch 90-degree attachment. And I'm just getting it on that slight lip, and then I'm gluing it so it's secure. Hot glue really is your friend throughout this process. It just keeps things in place as you're working on them, delicate things like this. So you can see this whole process, all I'm doing is I'm wrapping the layers and I'm gluing it when I need to keep it all nice, tight, and uniform. I think by the time I'm done, there's like 14 layers, or the coil is 14 turns. That's how you would call that, but that means 14 wire lengths high. Something around there. You can see I'm gluing it, moving it around, coiling it up, still coiling it up. I'm gluing it, coiling it up, Still coiling it up. And it's a delicate process, taking my time. It'd be easier if I had done this before, but this was the first time I had used PVC because of its insulative properties. And actually, this is pretty much based off of Michael Chapala's work. I saw how he had done his, and I thought to myself, well, I could take his paddles and incorporate them in the spark gap machines that I was building. And that's how this came to be. There I go, I'm hot gluing that top lip into place. And you can see that wire coming off the coil. That's going to go into that next strand of Romex. Yeah, I wrote it too. I'm cutting and stripping another length of Romex to connect with the wire leaving the coil. That's what I was just saying. I twisted the end of the 3 wires together to functionally have 1 wire. All right, there's me burning it. Here's me twisting it. So that red wire coming off the top of the paddle that I was just working on is going to go into this. And that's the other end of the coil. So one end of the coil came from the other paddle. And that paddle, it's just a continued, that paddle's, the other side of its coil came from the spark gap attachment. So that's how we got to where we are. All right, for this part, I cut the wire at the end of the coil, and I just made sure to cut it long enough so that I could wire it into the Romex that I'm about to put into the center of the paddle. Right after this, you'll see. There we go, getting it stripped. I've got the coil stripped now. This is the end leaving the paddle. After this, the wire is going to go to ground because this is the second paddle. I've already done this process with the first paddle. Now I'm threading it through. Alright, this I'm just hot gluing the Romex wire in place. At this point, I'm wire netting that coil and the Romex together, the 3 strand that I turned into 1 strand. And now it's slightly off camera, sorry for not showing it correctly, but I am duct taping the coil down. Even though there's hot glue, I want to make sure that coil does not move around. Because as we move the paddles, there's going to be some strain on the coil. Okay, for this process, I'm taking plastic wrap, that's regular plastic wrap that you buy at the grocery store, and I'm wrapping the PVC, especially the top, because the coil is a thinner gauge, and I don't want any stray voltage to shock anyone that uses it. After I put the saran wrap or the plastic wrap down, I'm taking duct tape and I'm covering all of it. And that's just to make the plastic wrap more resilient. So this is a long process, you can see. So I'm going to go ahead and skip ahead. That's what the 2 paddles look like all done, all taped up. You can see the bottom of the paddles, the bottom of the 2-inch PVC. I've duct taped those very strongly, very firmly. Put a lot of duct tape there. Now what I'm doing is I am cutting or stripping the end of the last part of the Romex. This one's going to get plugged straight into the ground on the cord that gets plugged into the wall. Right there I go. I'm still stripping it. Burning that wire. Now I'm pulling it off, and I'm going to twist it all together like I've said a few times now. Turns that 3 wire into 1 wire. This is like the cheapest wire you can buy. And there's the high voltage power supply. I'm grabbing the wire nut on the green cable, the one that goes to ground, and now I'm twisting them all together. It's easy as that. Alright, now I'm making an adjustment in the container. I'm cutting these little grooves for the wire to fit into. This isn't necessary, but it makes the whole product cleaner. We're going to jump ahead. Now that I cut the grooves, what I'm doing is I'm using a little bit of duct tape to reinforce the plastic there, or the cuts near the cuts, just so I can open and close that lid and use it like it should be. You can see how I've separated the wires. I made 3 grooves. This container, the high voltage power supply, is the most important part of all of this. It needs to be, the oil needs to be contained within it and not leaking. And it needs to be covering the dimmer switch and the car ignition coil, or at least 2 of the terminals of the car ignition coil. That's why I'm taking my time with this. I want it to be just right. And it never is, but this is pretty good. I got that container from like Dollar Tree or something like that. It was $1, $2, something like that. And the whole paddle, while you're using it, is going to be pulling on that high voltage power supply. So everything in the container. Now what I'm doing is I am going to use mounting tape. I believe that's the 40-pound mounting tape. And I'm just cutting it to fit right now. I'm going to use that to keep the power strip in place. And then I'm going to end up using that too for the bottom of the high voltage power supply, both on the very bottom and like almost like a seal between the sides of the container and the bottom. That comes in a little bit though. Cleaning the dust off, and I'm putting the power strip where I want it. Looks like a good place, right on the corner. That power strip is going to function like an on and off. There you go. I'm sizing up the bottom of the container. We're just going to jump ahead now. I should have said zoomed ahead. We're at double time. You can see I'm getting that on there. And we want nothing to move around. The only thing we want to move around is the paddles. So the attempts from this point, now that everything is put together, we're not adding any more components. We're just going to secure everything. So that's what I'm doing right now. I'm drilling some more holes for some more zip ties. Double time. This is actually triple time, for the record. I got the zip ties in. Checking everything. Alright. Now what I'm going to do is I'm going to secure that second paddle, the wire, the Romex wire leaving it, with 3 zip ties. Triple time. Alright, first zip tie secured, and this is to make sure, again, that there's no movement of the high voltage power supply station. We just don't want that moving around because it's going to have oil in it. Number 1, it's going to get messy if it does, number 1. And number 2, we don't want to burn out the dimmer switch if it gets exposed to the air. The dimmer switch needs to be in oil. Alright, we're back to double time. We've left triple time. And I'm drilling more holes into the board on the other side to secure the second ignition wire. and the first Romex cable that goes into the first paddle. I think there's kind of 3 or 4 more zip ties. Triple time. All right, getting it on there. Getting those zip ties through the holes. Making sure I put them the right way. I put one the wrong way. I had to redo that. That's the one right there. It's funny how you remember these things. Zip. Zippity doo tie, zippity a. Alright. Now what I'm doing is I'm taking the mounting tape and I'm sealing that edge just to add strength to the high voltage power supply. Because you can't run a screw through there, and hot glue is not very effective. Alright, now what I'm doing is I'm filling it up with vegetable oil. You can use any oil. Vegetable oil is just what I've got.
A GFCI tester. I'm going to open it. I'm going to show you what I mean when you need a true ground. Ready? Okay, see, no lights on right now. These 2 lights, according to this, is correct. If these 2 lights are on, not all 3 lights or not any other configuration, then we have a good ground. That's why you need to get one of these if you build one of these. All right, let's see if it works. All right, that's it working. This power strip is grounded correctly. There's the power plugged into this configurement here. It's running right now. There's oil contained within this container, but the container has a capacitor on it, or a capacitor, a dimmer, and an ignition coil. You can see the ignition coil from the outside. That's what this wire is right here. This wire comes off. It goes through this stainless steel braided wire. That's it right there. The orange glow is because it's heating up that wire. So not ideal, but it will do. You can move that wire around if it burns up. It goes to another ignition coil, which goes to some wire here. This Romex ends up going to this paddle. This paddle's got the coil in it, like I said. This paddle is linked to this other paddle right here, which has got the coil on it right up top at the 90-degree angle. As that goes, it goes back to the ground through this and right there. And that's the ground right there. And the ground goes, of course, to the outlet. So the black and the white lead of this, the hot, and here's the hot, this black wire right here, and here's this white wire. That's the neutral of those complete the circuit that powers the ignition coil right there. And then, like I said, the high voltage comes off the center of the ignition coil and goes through here, goes through that loop of the paddles, and then goes back to ground. You'll have to excuse this mess. I'm in between projects. Okay, there she is. Here's the mess too. But just as I explained it, the hot and the neutral end up powering the car ignition coil. The car ignition coil circuit is a dimmer, a 5 or 6 or 4 microfarad capacitor from an electric fan or a ceiling fan into the car ignition coil, and then the other side of the car ignition coil goes back to the neutral. So the hot side is what I said just a second ago. The neutral comes back to the plug here, Well, geez, let me re-say it one more time. I'm going to tell you one more time the circuit. This hot lead right here, which plugs into this power strip right here, this power strip plugs into a good ground, all right, a correct ground. You need to test with a GFCI tester. This black wire, first thing it does is it goes to a dimmer switch, which is contained in here. That dimmer switch goes to a capacitor. That capacitor is an electric fan capacitor for 4, 5, or 6 microfarads. You can use any capacitor at 4, 5, or 6 microfarads. Both of those, that goes into the positive side of this car ignition coil, which is, again, contained within this also. On the negative side of the car ignition coil, because there's 2 terminals and then one big high voltage terminal. The smaller terminal is a negative voltage. There's negative. That goes straight back to the white wire. That's what this white wire is. I just cut grooves in this so you could see, or so it would hold better. Okay. From there, those 2 are powering the car ignition coil. That's your high voltage power supply. The reason that it's in this container is because you fill this up with vegetable oil and you get it completely over the dimmer switch is the most important to cover the vegetable oil with, but it's also important to cover the terminals, the positive and the negative of the car ignition coil, so there's no spark jumpage. That goes into this car ignition coil. This is the high voltage power coming off the top of the car ignition coil, which goes right into here. Into here, we've got it clamped to a piece of stainless steel braid. This stainless steel braid is spark gapped into another stainless steel braid. That stainless steel braid, it goes to this car ignition coil. It's clamped onto that car ignition coil. Sorry for the lighting. It's hard to see that. Okay, that car ignition coil, this is the mess from just building this, goes into this car ignition wire, which is the same as this car ignition wire. These car ignition wires, you can get them, they go for the car ignition coil. So when you go to buy that coil, that 12-volt coil or 6-volt coil, get the wires that go with it. This wire, it clamps onto this wire, this Romex here, which is a 3 braid. What I did is I spliced the ends and twisted them together, so it became functionally 1 wire. That's hooked up to that. That goes around and around and around to this paddle. Again, excuse the mess, I haven't cleaned yet. This paddle has got a coil at the end, like I showed you. That coil, it goes from that wire, it goes to the coil. Then from the back side of the coil, it goes to this wire right here. This wire goes up into the second paddle. The second paddle has got a coil in it too, just like the first. Then it wraps around and it goes back down into this wire. This wire comes around. Let's follow it. And it gets zip tied into place and goes straight to ground. Okay, that ground goes back to the correct ground because we've tested it with the GFCI tester, and that completes the circuit. And what this does is this produces high voltage right out that coil, but the whole thing produces high voltage. So the whole thing is resonating. But this particularly right here is producing a EMP, right? And it's not the world's biggest EMP because this is contained within a 2-inch PVC elbow, right? So that's a 90-degree elbow there. And there's the 2-inch PVC pipe. There's 2 of them. All right, that's the machine. It's not that hard to build, just takes time and effort and a little bit of money. God bless. And may God have mercy on us.